Is Math Real? And Other Existential Questions is a book by mathematician Eugenia Cheng. It explores the misconceptions and myths surrounding math, challenging the notion of clear-cut right and wrong answers. The book delves into thought-provoking questions that provide a new perspective on mathematics. Arcane, arcane. Arduous, arduous. Tailspin, tailspin. Exponentials, exponentials. Pandemic, pandemic. Logistic, logistic.
Algebra, geometry, trigonometry, calculus. For a lot of people, these words dredge up old feelings of boredom or dread. And that's because when a lot of us encounter math in school, it can often feel like this arcane set of rules, a baffling series of letters and numbers and arduous problem sets. And to what end exactly, right? Like, how many of us have said to ourselves, when am I going to actually have to use this in life? And because of all this, some people grow up to have feelings about math. Like, math is scary or opaque, or that is not for me, but it's for somebody else. This is The Indicator from Planet Money. I'm Adrian Ma. And our guest, Eugenia Cheng, just put out a book called Is Math Real? And in it, she argues that regardless of the grades you got in algebra, math is actually something we can all nerd out on. And once you see it like this, she says it can change the way you see everyday things.
Hey, Ray Magliozzi from Car Talk here to tell you about NPR's newest offering, Car Talk Plus. Car Talk Plus subscribers can actually search through hundreds of classic episodes of Car Talk to find their favorite calls about cream rinse, marital disputes, foreign accent syndrome, and occasionally cars, too. Find Car Talk Plus at plus.npr.org/cartalk.
Eugenia Cheng is a mathematician and scientist in residence at the School of the Art Institute of Chicago. Her new book is called Is Math Real? Eugenia, thanks for coming on The Indicator.
Thank you so much for having me.
Can you tell me what inspired you to write a book with a title that is already sending me into an existential tailspin?
I hope that's a good existential tailspin. And I would like to remind you that there's a subtitle as well. So it's not a whole book about whether math is real or not. The subtitle is How Simple Questions Lead Us to Mathematics' Deepest Truths. And that's really what it's about. It's about the fact that math seems like it's about answering questions, but really it's about asking questions. And I meet so many people who say that they tried to ask questions in math class at school, but they were told that their questions were stupid or that they weren't the point of math, and so they got put off math forever. When actually, I think their questions are really great questions, and they're the same kinds of questions that mathematical researchers ask that push us further and further into research. Like, why does 1 + 1 = 2? What is a number? What is 0? Why is math the way it is? Things like that.
These sound like simple questions, but I have never really stopped to think about, like, what is a number? And I think that's where the existential feeling comes from, because I sort of think about math as something that is essentially a rigid set of rules that provides order to the world. And you're coming at it from a different place.
Yeah, I'm coming at it from a very different place because although it can seem like it's a rigid set of rules, unfortunately, that's quite off-putting to people who feel like asking more existential questions or like open-ended questions that don't have black and white, clear-cut answers.
Right. I mean, in your book, you say part of what you want to do is dispel some myths and clear up misunderstandings about math. What are some of those myths or misunderstandings that you are talking about?
Well, one of those myths is that math has clear right and wrong answers, that it's about absolute truth. There's a myth that math is not creative, that it's very rigid. And I want to dispel that as well, because I think it's all about mental flexibility and about being able to see things from different points of view at the same time. People often say to me, oh, well, math has clear right answers because 1 + 1 just is 2. The thing is that 1 + 1 can sometimes be other things. If you put one thing with one thing, you don't always get two things. If you mix one color of paint with another color of paint, you don't get two colors of paint. You just get one new color of paint.
Okay, but it sounds like we're not talking about math anymore.
So that is a genuine mathematical situation. Another one is if you turn a piece of paper over and you turn it over again, you get back to where you started. Or if you're standing by the elevator and someone comes along and is the kind of person who thinks you're dumb and hasn't pressed the elevator button, so they come and press it again, then you don't call two elevators. The second press of the elevator button doesn't add anything to the situation. So that's another mathematical situation. And those have fancy mathematical names. I mean, it's serious math. One of them is a binary operation. I did the cyclic group of order 2. That's when 1 + 1 = 0. There's also the concept of an idempotent, when 1 + 1 = 1 because the second one doesn't do anything. Those are genuine things.
Okay, I can feel my brain stretching a little bit because this is not typically the way a lot of us think about math. But, I mean, it also sounds a little abstract. I think some people would say that, well, what about the rest of us? You know, most people are not physicists or engineers that you need to use math in their everyday lives. Maybe at the most, we're calculating the tip on a restaurant check.
Honestly, the math you learn at school, you're very rarely going to need to use it directly in your life. Most people don't go around solving quadratic equations. And so then everyone realizes it's a scam, that you've been told it's useful when it's not. So what's the point? Whereas I think that it would be better to say it's a way of thinking. It's a way of using your brain better.
Okay, so what would be some examples of how math helps you use your brain better?
So it would be helpful for everybody to have a better understanding of, say, compound interest, so that they understand how dangerous debt is if you don't at least pay off your interest. But another example is about exponentials.
Okay, so that's where the numbers go up through repeated multiplication?
That's an exponential. And so, unfortunately, at the beginning of the pandemic, there were people who understood exponentials and there were people who didn't understand exponentials. And if you understand exponentials, you know that when you multiply numbers together, they grow really, really fast. So the model of viruses is called the logistic equation, and it starts exponential at the beginning, but then it tails off when you start running out of people to infect, basically. And this got really confused in the public discourse because some people thought it just meant that you don't have to do anything about it because it slows down. But it only starts slowing down because everyone's already infected.
So those are some ways in which math helps us think more clearly about the world. And you argue in your book that math is actually more intuitive than we give it credit for. And that even goes to the origins of math itself. It's like you have a whole chapter with a very basic but kind of profound question, which is, where does math come from?
Math comes from spotting patterns in the world around us and then wanting to do something about that. So, for example, if you notice that if you take one banana and another banana, say, and then you get one apple and another apple, then something similar is going on in both of those situations. And then maybe you want to be able to say that generally. So then you come up with some way of saying it. That's where you get one thing plus one thing equals two things. And that helps our poor finite brains make sense of a very, very complicated world around us.
Yeah, I guess when you put it that way, it's like the written word allowed us to kind of go beyond our brains, so we didn't have to keep it all in there. Math is essentially a way of helping us extend our brains into the real world with a new kind of language.
Yeah, it really is a more effective way to use our brains. And that's what math does. It finds really effective packages and then puts the packages in packages as well. And then we get to use our brains more effectively.
So math isn't just a rigid set of rules handed down from on high. It comes from people wrestling with the world and trying to understand it.
Yeah. And the rules are there to help us. And it's a bit like, well, here's a somewhat controversial thing maybe, but it's like laws in society, right? Laws are supposed to help the smooth running of society. If the laws go too far, then you get an autocratic society, and that's no good. And if there aren't enough laws, then you sort of get chaos and anarchy. But if you have the right amount of laws, then they help society to work correctly. Just like traffic lights and traffic rules are there so that we can actually drive up the street and hopefully not have too many crashes. And so that's really what the rules in math are for. They're there to keep things organized, but they're not supposed to be just imposed arbitrarily. They're all there for a reason, to keep things running smoothly. And if we didn't have enough rules, then we'd have chaos and we wouldn't get anywhere. But the trouble is that the rules are often presented like they're handed down from on high, rather than developed as something to help us as we go along. And I think if we presented it and let people sort of make up their own rules and explore what the consequences are, then I think that we would put people off math much less, maybe not at all.